Greetings guys, this is Magnanimous Minds Lectures Online. Today we are doing Engineering Science N1 Motion. Here we are given a question whereby there's a table which has time in seconds and velocity in meters per second. The question says determine from the graph the velocity after 2.5 seconds, time taken to reach a velocity of 15 meters per second. And then we're also told to determine the acceleration and also the displacement after 4 seconds. So the best thing to do is to first plot this graph so that we can read off what's needed from us, since they're saying determine from the graph. So to draw the graph, we are going to use the information given, which is this table. Here I've just drawn a set of axes whereby 1 second equals to 1 centimeter, and also 1 meter per second is also equals to 1 centimeter. So it's 1, 2, 3, 4 meters per second, 5, 6, 7, 8 meters per second up until 20. So to draw that, we'll start with 1. At 1 second, which is here, our velocity is 4 seconds, and at 2 it's 8. Let me do this. There we go. At 2 it's 8, and then at 3 it's 12. So 3, and to mark out 12 there. Then at 4 it's 16. Therefore we're going to mark our 16 here. And this should be 16, not 18. 16. And then at 5 it's 20. Which is right here. And you have to make sure that you use your ruler properly, and this line, these dots are directly at 4 and 1, 8 and 2, 12 and 3, 16 and 4, 5 and 20. Because what's going to happen is that you're going to draw your straight line graph from this information, and if your points are not proper, you're not going to get that straight line. So let's try to draw that straight line. It's going to be should be something like this. And it passes through 0. So we've got this point where it's 20 and 5, this point 16 and 4, we've got this point 12 and 3, we've got this point 8 and 2, we've got this point 4 and 2. And then now we start answering the questions. The first one says velocity at 2.5. So we go to 2.5, which is right here in the middle of 3 and 2 seconds. So it's going to be right here. Then we take our ruler, we draw a straight line up until where it touches the graph. So it's going to go all the way up like this. Then it touches the graph there. Then after touching the graph right here, you draw a perpendicular line which touches the y-axis, which is the velocity. then it comes here. Then from there you read off according to the values. The values are, we've got 7 here, we've got 9, we've got 10, we've got 11, and this, it's in between 9 and 10, so this is going to be 10.5. so that means at 2.5 seconds our velocity is 10.5, so our velocity is going to be 10.5 meters per second. And then B says time taken to reach a velocity of 15, so we go to the velocity axis and we find 15. If we check here from 12 to 18, we've got 13, 14, 15 and 16, so 15 is right here. So what we do is that we draw a horizontal line from the y-axis to the graph, and that line is going to be like this.
Your device is disconnected.
And then here's the point. Then from there we draw a vertical line from that point to the x-axis, so that's going to be something like this, and we make sure that it's perpendicular to the x-axis, which is the time axis. It comes here, and if you are to look at this right here, it's 3.5, so this something like 3.6, so it's going to be 3.6 seconds. Then from there we have the acceleration. We're told to calculate the acceleration, and we know that acceleration, it's the gradient of the straight line, because according to the formula, acceleration equals to velocity over time, so it's equals to this velocity over this time, and we usually use change in velocity over change in time to get the average acceleration. So our acceleration is going to be, let's say, v at 2 minus v at 1 over t2 minus t1, and from the graph, that's from here to there, so we can represent the gradient as this. So this is change in v, and this is change in time, and then our change in v, it's going to be 8 meters per second minus 4 meters per second over that 8 is 2, so it's going to be 2 minus, and at 4 it's 1 minus 1. This gives you 4 over 1, which is 4 meters per second squared, because here you've got meters per second, and here you've got second, so this meters per second over second becomes meters per second squared. Then now we go to question D, which says calculate the displacement. And to calculate the displacement, or to determine the displacement from the graph, we go back to the formula, which helps us to find what you call velocity. V equals to displacement, I think it's written as over time, whereby we usually use change in s over change in time, and then our change in s will be equals to v change in time. Then this is going to be s at 4 seconds minus s at 0 equals to v t at 4 minus t at 0. Then displacement at 4 seconds, that's what we don't know, but displacement at 0, it's 0. And then our velocity is the velocity at 4 seconds, and our velocity at 4 seconds is 16, so it's going to be 16. And time at 4 is 4 seconds, and time at 0 it's 0. So our displacement is going to be 16 times 4, which is 10 times 4, which is 64 meters. And that's it for this question. Thanks for watching Magnanimous Minds Lectures Online. Please do subscribe to our channel, as well as liking our videos, also following us in our social media pages. Facebook, we're Magnanimous Minds. Instagram, Magnanimous_Minds. Twitter at Magnanimous Min1. Thank you.